Okay, so I have three things on the board. A is solution, B is colloid, and C is suspension. All right, let's do number one. All right, let's do number one. All right, which one of these does not settle out on standing? A, B, or C? If you mix the two things together, they're not going to settle out on standing. A, B, or C? Yes? Which ones? Which ones? No, we don't need letters like you're looking up the answer in the book. Does a solution settle out? Does a solution ever settle? No. It can be suspended. The particles are so small that the water has no problem suspending them. Okay? So this is definitely one. Okay? How about a colloid? Well, yeah, what's the difference between a colloid and a solution? It's a very simple difference. What's the difference? What's the difference? What's the basic difference that leads to all the other differences? What's the basic difference between a colloid and a solution?
The particles are larger.
Yeah, larger particles, that's it. Haley's right, the particles are larger. Okay? And what's the difference between a colloid and a suspension?
The particles are even larger.
The particles are even larger, but just between a colloid and a suspension, apart from the particle size, what else is it? What else is different?
The suspension, gravity affects the particles.
Okay, you want to put that in English? I'm not sure what language that was, but it certainly sounded, people may not understand it. It was an excellent answer, by the way. It was a little too textbook. Are you okay?
Yeah.
Okay, good. I just have to check every once in a while. Okay, so what's the difference between a colloid and a suspension? The suspension will settle out. It'll settle. Will a colloid settle? No. The size of the particles are small enough, so that's not going to settle. Okay. What about number two? Heterogeneous mixture. Which ones are heterogeneous in nature? In other words, there's two phases. There's actually, you can identify literally two things in there. A, B, or C, or solution, colloid. Anybody want to help out? Where's my answer crew here? Okay. What do you got, Anna? Yeah, a colloid and a suspension. A colloid and a suspension. They won't settle. I'm sorry, they will settle. They will settle, and the colloid won't settle, the suspension will, but they're heterogeneous. I'm sorry, I lost my place for a second. Okay, what about particle size less than 1 nanometer? What's a nanometer? What's a nanometer? Anybody?
10 to the power of 9.
10 to the negative 9, right?
Yeah.
So a billionth. So how many nanometers are there in a meter?
9 billion.
Yeah, right. So a billionth would be, right? That's a billionth. 1, 2, 3, 4, 5, 6, 7, 8. 8 zeros and 1. Because it's going to go negative 9, right? TJ, you with me?
Yeah.
So 1, 2, 3, 4, 5, 6, 7, 8, 9. Right? You get it? Or there are a billion nanometers in a meter. Right? What am I doing? What's wrong with this? Oh, sorry. Sorry. Yeah, that's a billion. I had 100 million. So it should be, you always can check, it's 9, right? So it's 1, 2, 3, 4, 5, 6, 7, 8, 9, right? So there are a billion. 1, 3 zeros, 3 zeros, 3 zeros, right? Clear? Okay. So big. So Which one has the nanometer, size of nanometer? Solution, colloid, or suspension?
Solution.
1 nanometer?
Yeah, solution. Okay. And what's that? Number 3? Yes? Like the fat molecules that are suspended. Milk is 4% fat, which is a lot of fat, if you think about it, right? If you have a big glass of milk, God, you have this layer of fat in it, right? So that's pretty big, right? What keeps the fat suspended? It's very simple. We've studied it. First section of chapter 15 starts with an H, 2 words. Second word starts with a B. Hydrogen bonding, right? Yes? You guys are looking at me like, did you know the answer to that? Taylor? Miss Taylor?
Yes. Yes.
Okay. All right. I believe you. Okay. Do we need to continue? Let's not continue. You get the point? Homogenized milk. We're going to go down to 7. Homogenized milk is what?
0 fat.
0.
No, homogenized milk, just, you can have homogenized whole milk, homogenized 2% milk. Homogenized just means it's completely mixed up. The fats, everything's dissolved. It's a colloid then. That means homogenized milk means it's a colloid. Okay? So what is homogenized milk? It's what number is that?
5.
What number is that? 5? Yeah, thank you. 7. Where'd you get 5 from? Are you guys with me today? Or I find that people are disjointed here and they're paying attention. Are you confused or preoccupied or something? Okay. All right, shall we do one more there? What about jelly? What's jelly? Haley? You have the answers right there if you're curious. Haley forgot.
Cool.
Haley, what do you got, girl? You don't want to tell me. You want to keep this a secret. The answers are right there, number 7. Shall I? Excuse me, I'm going to show her where the answers are.
No, I see it.
You see it? Okay. So, which is the answer? 7? No, 9, right? Isn't it 9? Right. Which one's right? But you gotta know which one it is. So it's number 9. So what is it? What is jelly? A colloid. Okay. Number 9. All right. Do you get the point? So you have to be able to identify jelly, salt water, homogenized milks. Particles are invisible to the unaided eye, etc. What are particles are? Particles are invisible to the unaided eye. Let's finish with that one. Number 6. Is that a solution? Is it? Yes or no?
Yes.
Yeah. What about colloid?
Yes.
Yes. What about solution? I'm sorry, what about suspension?
No.
No. All right, you with me on what to do with that? So you have to be able to identify solutions, colloids, and suspensions. Got it? Okay. That was painful. That was painful. I'll have a heart-to-heart with them. Okay, at the end of this film. Okay, good. Can we quit? Okay, good. Okay.